Hello everyone, welcome to second math lesson. And today I'm going to be going over this exam 1 study guide for calculus for business and social sciences. So this will cover the first 2 chapters of the textbook, which will be on derivatives. And you can see here there is going to be some cost, revenue, and profit functions, also limits, supply and demand functions, finding the equilibrium, quantity, and price. There will also be questions on logarithms, exponential functions, and also compound interest. So also in the material being covered, here we'll have differentials. Also questions on marginal cost, average cost function, and the marginal average cost function. So let's start off in the beginning. Here we have some questions on the derivatives. So for question 1, derivative of a constant. So for the answers, I'm going to just write it on this separate piece of paper here. So we have the exam 1 study guide. And we'll start with question 1, which is the derivative of a constant. That's going to be d dx of c, and we know that is equal to 0. So for the next question, the power rule, here we have d dx of x sub n. So right here we got question 2. For the power rule, d dx of x sub n, that's equal to nx to the power n minus 1. For the derivative of c f of x, that's going to be c f prime of x. Then we also have the sum rule, d dx of f of x plus or minus g of x. That will equal to f prime of x plus or minus g prime of x. So how about in question 5? Here it says to find the derivative of f of x. So if we get the derivative, it's going to be just 0. For x to the 5th, we have 5x to the 4th. X to the 3.1, we have 3.1 x to the 2.1. If we have 3x squared, we get the derivative. It's going to be 6x. If we have 9x to the 1/3, then we'll have 9 times 1/3 x to the 1/3 minus 1. That will simplify to 3x to the negative 2/3. If we have 3 rad x, then we'll have 3x to the 1/2, and we get the derivative, so it's going to be 3/2 x to the negative 1/2. So question 11, we also take the derivative. Here we got f prime of x equals negative 84x to the negative 13. So in question 12, f prime of x will be 10x minus 3. Question 13, f prime of x equals negative 3x squared plus 4x. So if we have this, and we want to get the derivative, here we'll have f prime of x equals 0.06x minus 0.4. 15. First, simplify f of x, so we'll have 2x cubed over x minus 4x squared over x plus 3 over x. We simplify it first. We have 2x squared minus 4x plus 3 to the x to the negative 1. Then we have f prime of x equals 4x minus 4 minus 3x to the negative 2. We got f prime of x equals 16x cubed minus 15 over 2x to the 3 over 2. Then we have f prime of x equals negative 5x to the negative 2 minus 8x to the negative 3. So 18a, it says to evaluate the limit if it exists. So for a lot of these, just plug in the value. Say x equals negative 1. So this limit, it's going to equal 3 to the negative 1 squared plus 4 times negative 1 minus 2. So we have 3 plus 4 is 7 times negative 3. We have negative 21. So that's part A. For part B, here we have this limit here. So if you plug in a 3, we don't get a 0 in the denominator, so this limit is just going to be 3 minus 3 over 3 plus 5, so we have a 0. Then in letter C, here we also just plug in the number. Here this limit is going to be equal to, first you can try to factor it to see if anything will cancel. So if you try to factor it, we got x minus 3, x plus 1, x plus 2, and x plus 3. So there's no cancellation. So we just plug in, we have negative 2 minus 3, negative 2 plus 1, over negative 2 plus 2, negative 2 plus 3. So we have negative 5 times negative 1 over 0 times 1. So we get a 5 over 0, so that's undefined. So we say the limit does not exist. Letter D. Here we have the limit as x approaches negative infinity of x plus 2 over x. So first we can split up the limit. Here we have x over x plus 2 over x. So we have the limit as x approaches negative infinity of 1 plus 2 over x. Then as x approaches negative infinity, 2 over x will approach 0. So we just have 1. Then in letter E, we have this limit. So we just plug in x equals 2. We have the limit will equal to 2 minus 3 over 2 plus 5. So it's negative 1 over 7. Here we have the limit as x approaches infinity. So we can split it up. We have x over x plus 1 over x. So that will equal to limit as x approaches infinity of 1 plus 1 over x. This will approach 0. So we have 1 in the end. Then letter G. Here we can try to split up the quadratic expression. We can factor it. So here we have x minus 3, x minus 1 times divide by x plus 2, x plus 1. Then we just plug in the negative 2. So we simplify it. We have negative 5, negative 3 over 0 times negative 1. So we got 15 over 0. So the limit does not exist. So now we're moving on to some application questions. Here it says the company has a fixed cost of $20,000 and a production cost of $5 for each unit it manufactures. Unit sells for $12. What is the cost function? So for the cost function, here we're going to take the variable cost plus the fixed cost. So here we get C of x equals, so it takes $5 to produce each unit, so it's 5x, plus the fixed cost of 20,000. So for part B, we have the revenue function. So for the revenue function, that will be R of x. And for the revenue, it says that a unit sells for $12. So we just take 12 multiplied by x. Then we can get the profit function. That's going to be the revenue minus the cost. So we get 12x minus 5x plus 20,000. Simplify it. So we end up with 8x minus 20,000. So letter D, it says to compute the profit loss corresponding to production levels of 2,000, 3,000, and 4,000 units. So here in part D, we're going to get P of 2,000, also P of 3,000, and also P of 4,000. So we already have the function P of x that's given, so we just plug in. We got 8 times 2,000 minus 20,000. Here we got 8 times 3,000 minus 20,000. 8 times 4,000 minus 20,000. And then you simplify it. So here we got a negative 4,000. Here we have 4,000. And here we got 12,000. Then you can finish up your solution by writing it in a sentence. So here we have some space below them. So you can put there's a loss of 4,000. Here there's a gain of 4,000, and here there's a gain of 12,000. Oh, actually, I think I made a mistake. Here it's supposed to be 7. Okay, so there's 7x. Here we got 7. So this is supposed to be 14 minus 20. So that's negative 6. Here we have 21, so it's 1,000. And here we have 28 minus 20, so it's 8 here. 8,000. So coming back here, we have number 20. The monthly demand and supply functions for the luminar dust lamp are given. So you have those, and find the equilibrium quantity and price. So number 20, here we just set the equations equal to each other. So you have those equations. We'll just set them equal to each other. We have negative 1.1 x squared plus 1.5 x plus 40 equals 0.1 x squared plus 0.5 x plus 15. Then we're going to move everything to one side. So we'll end up with a 0. That's 1.2 x squared minus x minus 25. Then you can use the quadratic formula. So that will be x equals negative b plus or minus the square root of b squared minus 4ac all over 2a.